a virtual machine has several components. At base we have the host, which is the underlying hardware which runs these virtual machines. On top of that, we have the hypervisor or virtual machine manager, which creates and runs these virtual machines. So, although they act just like an independent computer, they do not run directly on this hardware. They run on those hypervisors, which we have been explaining in a little while.
Alright, so a hypervisor. A hypervisor is something like a software which enables us to use multiple operating systems inside our physical machine. So when it comes to hypervisors, so you can see a hypervisor is a software program that enables multiple virtual machines run on a single physical machine, and which is known as VMM, or a virtual machine monitor or virtual machine manager. So by using hypervisors, we can deploy and run virtual machines and manage resources and ensure isolation. So this is the best part. So who want to see how really virtual OS work? I'll show you. So give me a second. To do this, you have to go to the console inside your Google Docker. I'll show you. I have something notepad here. You can see the steps is this. First, open this link. I'll give you in my WhatsApp group, our WhatsApp group. I'll share this with you. First of all, open this link. I'll open it with you guys. So this is Google Cloud, as you all know, right? So you just need to go to your shell here. You can see activate Cloud Shell and open it. So now I'm going to show you how I use an OS on top of an OS. Okay, let's see. So alright, so this is our Cloud Shell. Alright, so here's some codes that I need to run on this cloud, on this shell. So I'm going to copy this sudo apt install docker. This is going to be explained by Rashid later. Alright, so next you have to run this code here. Alright, so it's still installing. This is completely free. You can use, everyone can use. Alright, so let's go to this web preview and change the port to 6080. And check and preview. Now, so here's the coolest part. You only have Rashid's laptop, she only has Windows installed, but now you can see this is Linux, this is Ubuntu. Okay, I'll just open an web browser inside this web browser. you can see I have opened Microsoft Edge, right? Inside Edge I have an operating system now I have loaded, right? So I'll show you the browser inside the web browser, right? Cool, right? So this is what OS virtualization is, or OS virtualization is. So let's move to the presentation. I'll carry on next to the next presentation slide. And so when it comes to hypervisors, we have two type of hypervisors. First one is type 1 and second one is type 2. And first one is actually does not have a host operating system, right? So it actually installed inside our physical components like CPU. It can control our CPU and our RAM. It can control everything. All right. For example, we have virtual, let's say, VM spacer and Microsoft Hyper-V. So those are the examples for type 1, which I have showed you just now. I use a type 1 virtual OS, right? So hypervisor. And when it comes to type 2, it is underlying and on a host operating system, and it will give us some other operating system like as Rashmi asked from Savi, does he need to open an Linux run on top of Windows, something like that. So for example, we can use VirtualBox, as everyone knows, and we have workstation. So that's what hypervisors is. So I'll pass the presentation for Vihan to carry on.
So there are different levels, or to be more specific, different techniques of virtualization. First, we will look at full virtualization, also known as hardware virtualization. In this level of virtualization, we create an exact virtual copy of the hardware environment, but the guest operating system is not aware that it is running in a virtualized environment. It instead interacts with the virtual hardware supplied by that hypervisor. Next, we have ARA virtualization. In this level, the guest operating system is notified and is aware of that hypervisor, and it interacts with it directly using something called hypercalls. And next, we have one of the biggest types, operating system level virtualization, also known as containerization. In this level, the host operating system's kernel is shared on several virtual machines, which are known as containers. And these containers are isolated from each other. They do not know that they are running next to each other. And that is done through several specific features, of which we can select two main features. The first of which is known as namespace. This namespace provides the appearance and the customization that each of these containers have its own operating systems. And next, the next feature is C groups, also known as control groups. The control groups monitor and meter these resources in order to ensure that the container does not attack its own system. A container is defined essentially in basically a single file known as the Docker file, and we can take that Docker file and run it on different machines, and which makes operating system virtualization highly flexible and scalable. Next, we look at the benefits and drawbacks of operating system virtualization. First, we look at the benefits. Rashmi will explain most of these benefits in a little while in high detail, so I'll just give you a brief overview of them. First, we have the ability to run multiple operating systems within one single system. Next, the host system is protected from the virtual machine, and also the virtual machines are protected from each other. Each virtual machine is isolated from each other, so they have little or no communication between each other. If one virtual machine gets a virus, there is a very low probability of it actually affecting the host operating system and also the other virtual machines because of that isolation. Next, we can freeze and suspend an instance. Most operating systems provide that function. However, virtual machine managers take it a step further and allows us to take snapshots and copies of that system. And using those copies, we can create new instances or even take that instance and run it on different virtual machine. It eliminates the requirement of system downtime. System developers can do their system development in that virtual machine assigned to them instead of directly on the physical machine. And through that, once they are done with the actual testing and debugging, they can run that. They can make that change to the physical machine, and only then will there be a downtime. Next, we have system consolidation, which combines several light used systems into one heavily used system. And next, we look at the drawbacks of operating system virtualization. Every coin has two sides, and just like that, operating system virtualization, with all of its benefits, also has some drawbacks. First, it could prevent the sharing of resources. Operating system virtualization is generally known for allowing us to efficiently share resources. However, each virtual machine is isolated from each other. They have little to no communication between them, so it makes it difficult to share resources between them. However, as a solution for that, we can create virtual communication networks, which are just like physical communication networks. Next, we have security risks. Although they are isolated from each other, the virtual machines, they are isolated from each other, but there are some instances when a damaged virtual machine could damage the host operating system as well as other virtual machines due to limited isolation. And also, if the host operating system crashes, it could crash the entire virtual network. Next, some systems are not virtualization compatible. For example, para-virtualization. We have to modify the guest in order to actually virtualize the operating system. However, some operating systems do not have that function, and for that we can use hybrid systems instead of using directly that function. Next, overcommitment problems and resource contention. When we allocate more virtual resources to a virtual machine than the physically available amount on the host operating system, that is known as overcommitment. This is a common feature in operating system virtualization. However, it could lead to several problems such as increased latency, which is the delay between the request and response, and decreased throughput, which is a decreased amount of resources that can be transferred between networks and processed by the system. Next, Rashmi will explain how operating system virtualization is actually used in practice.
So, OS virtualization is used in practice in a variety of ways to increase greater flexibility, scalability, and efficiency. OS virtualization nowadays has become a critical part of IT infrastructure, and modern organizations are continuously getting OS virtualization to modernize their computer systems. Self-consultation. This is one way of using OS virtualization for companies, and here you can see there is only one physical server, but there are multiple virtual servers. In that way, you can manage, reduce hardware costs and improve hardware resource utilization. And then development and testing. In OS virtualization, there are thing called containerization. Containers. I think Nihan and Nihan both explained what the container is. And in development and testing, they can develop software in different containers without affecting the other containers. And cloud computing. Containerization is an important aspect of cloud computing. It allows applications to be easily moved between different clouds. And then application deployment. Here you can see there's only one hardware, and then there's virtualization there. And inside those different operating systems, there are several applications running. So one application can run without interacting with the other application. And then disaster recovery. Think if your server got catch a fire, and with OS virtualization, you have all those physical servers. It's like cloud computing, so you can recover in the disaster easily with OS virtualization. And then security. Virtualization can be used to create isolated environment. When you're doing bank transactions, that will increase your security by dividing it into containers with isolated environments. And then legacy application support. What do you mean by legacy application? Do you know what a legacy means? You know, legacy of your school, carrying out the legacy. Legacy means the applications that are outdated or old, which means now you can't use legacy application in modern operating system. But with OS virtualization, that enables you to use legacy application in modern operating system. Alright, now let's see how real-life companies successfully implemented OS virtualization. This is it. It's an online marketplace. I'm sure that most of you have probably heard about, haven't probably heard about Etsy. It's the European and Western world fashion online marketplace. It's so popular within Western world. Etsy is a website that have millions of active users and billions of page viewers per month. So let's see how Etsy has implemented OS virtualization. And this Etsy, as I told you, it's an online marketplace. When online marketplace is growing, their online needs are becoming more and more. And with large and complex infrastructure, Etsy was growing in their own success stories. So there are hundreds of physical servers, various range of software applications. So literally, Etsy was running out of room to house all those servers and software applications. And how Etsy's engineering team overcome those challenges? Yes, you all guessed it right, it's OS virtualization. So, Etsy's engineering team used OS virtualization through Docker. We have also used Docker, so Etsy is a huge company with millions and billions of viewers. Even they have used Docker. And what is Docker? It's an open source containerization platform. We have used it for free, so it's open source, and that allows developers to package applications and their dependencies into lightweight, portable containers. Using Docker, Etsy's engineering team was able to streamline their deployment process and to reduce the number of physical servers needed, which means they used virtual servers instead of physical servers. And they improve the scalability of application,